Today I'm going to talk about how I did 3 different kinds of neural network implementations. So as you can see, this is my GitHub repo where I have everything. So the first thing is using NumPy from scratch and doing manual backpropagation. The second one is using PyTorch and doing fully manual implementation. And then the next one is like using a class-based model in PyTorch and using the torch.nn.Module. The fourth one I used was PyTorch Lightning and using automated training loops. And then the fifth one is TensorFlow from scratch and without any high level APIs. And then the next one is the TensorFlow but with built-in layers. So implemented the same neural network but using TensorFlow's built-in layers like the dense and all the other layers we have. And then the next one is like using the functional API with TensorFlow, and I use the tf Keras model. And then the next one is like using like model API and then subclassing the tf Keras model. And then the last one that I did was using Sequential API, which is like nothing like it is the simplest version of the model. And then I stack the layers in a linear order with automatic weight initialization. So as you can see, these are all the key features that we have described in our collab. So I'm going to talk about all of these and let me just open the collab. Okay, so this is the first section where I'm just taking a few cells, a few values, and then you can see that I've just taken some random values and like I used a 3-variable nonlinear equation and I generated synthetic data, which is nothing but numbers. And then this, as you can see, these are the ones. And then this is the nonlinear equation where I've taken all of the 3 variables and I gave a function for that. And then this is nothing but I'm just visualizing whatever are the variables, the x1, x2 and the x3 variables. And then this is the second section. Like the first section focused on generating the synthetic data and like checking how the data is. This section I'm just doing all of the neural network implementations, as you can see. So the first one is NumPy from scratch, implementing a 3-layer deep neural network with manual backpropagation. The second one is PyTorch from scratch, implementing a 3-layer neural network with using built-in layers. Then we have the PyTorch module based, which is nothing but using the module system to structure the neural network. We have the PyTorch Lightning version. Using Lightning, we'll just do the same 3-layer neural network. Then we have the TensorFlow from scratch. Implement a 3-layer neural network manually, avoiding high-level APIs. And then using the built-in dense layers and all of those layers, we are doing one of the implementations. And then the next one is the functional API. So yeah, and then this is the NumPy from scratch. So I have 3 layers. The hidden layer one has 10 neurons, the second one has 5, and then the output layer, as usual, it will have 1 neuron. And then this is the linear activation, so I'm just doing all of that. So defining the loss, the ReLU and the derivative. This is the neural network that I'm doing. So the forward pass, backward pass for the back propagation, all of that. This is the training part. I'm just taking the data set, which is nothing but the variables that we have defined before, and then the outputs will come as y. And then this is where I'm initializing the neural network, and this is the training part for that. And I gave about 1000 epochs for that. So it happens in this like multiples of 100. So this is a training loss curve, as you can see. So if you see the accuracy, we got around 72%. Yeah. So this is a PyTorch from scratch, and then the same thing over here. We're doing whatever we did before, but here we are doing it with PyTorch, and we are implementing a 3-layer, like fully connected neural network for nonlinear regression. And this is also from scratch, defining all of the activation functions and their derivatives. This is a 3-layer neural network class that we're doing, and we're not using any built-in layers. We're doing all of this from scratch. So this is for the forward pass, the backward propagation, and then updating the weights and biases over here. This is a training loop which will train, And then these are nothing but defining the x and y values. This is where we're calling the training function. This is the training part, and as you can see, this is all about the training loss curve of this. And then this is the implementation of this three-layer neural network using PyTorch, like built-in layers. So we have the torch.nn module, so we are just importing that, and then using all of this. So this is the module that we are defining. Then we're taking the functions directly from the NN. So we have we have three whole layers, but then the first two are the hidden layers, and then we have the output layer. This is for the forward pass, and then we're doing the training part, and this is the model, um, defining the loss function and also the Adam optimizer over here. This is a training loop, and then this is where we're doing the forward pass and backward pass and the training. So as you can see, this is all about uh, the training loss curve. And then this is the implementing a three-layer neural network using PyTorch Lightning. So we have something called as a PyTorch Lightning, which is nothing but it's a higher level API for PyTorch. It is like designed to make deep learning model training more structured, efficient, and scalable. So the first step we do is we have to install that. And then after that, this is the neural network definition. So using the Lightning module, we're just defining a class for the model. And then here we are defining the layers, and then training, forward pass, and then we're doing the Adam optimizer part here. This is our data set, we're just loading it. And then this is where we're initializing the model. As you can see, all of the parameters are being sent here, and then we are using the inbuilt trainer that we get. So that is what we're using here. We don't have any function defined specifically for training. So yeah, this is all about the PyTorch Lightning. So you can see the training loss curve, and it says epochs 100 reached, and yeah, this is all about the PyTorch with Lightning. And then this is using TensorFlow. We're taking the Keras API, so because it simplifies model building and automatic so these are the advantages of using Keras API with TensorFlow, I would say. So these are the layers, as you can see, the hidden layers and the output layer. This is for the forward pass, and then this is the dataset optimizer, loss function. This is the model, and then compiling the model, fitting the model, and then this is all about the training. Yeah, this is the training curve, as you can see. So the loss keeps on decreasing. And then this is the same thing, yeah, like using TensorFlow, but without using high level APIs. We'll be doing our manual training loop. So we have defined all of the parameters over here, and then this is the weights and biases that we're defining for each of the layer manually. This is the X and Y training, this is the forward pass, and this is the mean squared error loss. This is the training loop, and everything else is done. Um, yeah, so after all of I think I gave around 400 epochs if I'm not wrong. Hmm. Yeah, sorry, 500 epochs since it starts from, yeah, makes sense. Okay, so we gave around 500 epochs, and yeah, this is all about that. And then this is implementing a three-layer neural network in TensorFlow using the einsum instead of the tf.matmul. So this is for the matrix functions, I would say. The same thing, like defining the activation function, initiating model parameters, initialization of weights and biases, converting the data set into like TensorFlow tensors, defining the forward pass, mean square error is done here. This is the training loop. Everything else done, and yeah, we've done it. We're fitting it, everything. So as you can see, this is a training loss curve. So this is all about what are the functions that we have in that. So like whatever we define in the forward pass, I just have a simple explanation of what is happening in each of the layers. And then we go to the implementing a three-layer neural network using the TensorFlow functional API. So this is the easiest one, using like the functional API. So as you can see, this is how we do it. Taking the data set, defining the input layer, the dense layer, first hidden layer, second hidden layer. Then this is the output layer. And we don't have any activation since it's like a linear regression that we're doing. So compiling, fitting the model, and then getting the epochs, the training part and the epochs. 500 epochs, as you can see. This is all about the training loss curve. And then this is implementing a 3-layer. This is the next one. So basically we move to the next one. So this is implementing a 3-layer neural network using TensorFlow model API. So this is we're using model API because it's more flexible than like sequential and functional API, and it's like easier to debug and also extend. So doing all of that, this is the neural network class that we have. This is the data set that we're converting. This is the call for the forward pass, initializing the custom model, and then compiling with optimizer and the mean square error loss. And then this is where fitting the model. So 100 epochs, as you can see, and this is the training loss curve. And then this is using sequential API. We're doing it like these are the built-in layers in TensorFlow. So yeah, these are the sequential layers, compiling the model and then fitting the model in this particular step. So I would say this is like the easiest one of all. Yeah, sorry for the confusion, but yeah, this is the easiest one. So this is all about three three-layer neural networks in different ways, how we can do it with PyTorch, TensorFlow, our own implementation, and yeah, different methods in all of these subclasses and everything. So yeah, thank you.